All right, so this is the second half of that worksheet. I said I would get to it, and I am getting to it today. And for those of you who aren't in the class that are trying to get a little algebra practice, we do a worksheet every day. I'm sorry you're not getting the one every day, because then you get a course, but we're gonna sketch this. I'm gonna draw. We're gonna talk about perpendiculars and do that problem through a point. We're gonna do a little foiling, multiplication, writing as products. I like to say that's what we're doing, taking the sum and writing it as a product, which is called factoring. And a lot of times students don't really know what they're doing when they're factoring. They're writing sums and differences as products. Going to write 49 minus 25 as a product as well. We're going to write this binomial as a product, talk about what the rules are governing that process. Over here, we're going to sketch this calculation, talk about it geometrically. And then we're going to take an ax squared plus bx plus c and get a little rep here on something we're doing in class. It's completing the square method that we're actually going to streamline so that we find an easier way. And we'll also do it as products. We'll do it from two perspectives. And I hope that, a month from now, you're graphing those in 10 seconds or less. And then we're going to write the equation of a quadratic through a vertex point, a 2, 3. And I just picked a random point. We want to be able to write those as quickly as we write the equation of a line. Understanding the numerics behind it might take a little longer, but we'll get some mechanical precision and then keep talking about what's going on. We're going to sketch that. We're going to find the y-intercepts of f and g. We're going to do g of f of 2, which could have been written this way as well. And that's, I think, how your SATs might put that before you. We're going to sketch f of x. We're going to sketch g of x using products. There's g of x. And at the end of the video, I said that the square root of 2 is 1.41, or the end of the worksheet, and the square root of 3 is 1.73, and that's an approximation symbol. And I want you to hear that. The more times you hear it, at some point you're going to know it. All right, so over the course of the semester, I'm going to be talking about that quite often because those values are absolutely essential to know when you study trigonometry, which is a major unit of study in typical textbooks and courses. All right, do I have a marker? Yes. Do I have an eraser? Yes. All right, this is called standard form. 2x, 2 times x, and we've already taught it's a product. All right, and what do we say that products should be multiplied by to get some understanding? What's the easiest number to multiply times? 0. So if we let x equal 0, it's like covering that term up, and I get -4, which happens to be a y-intercept. Let's call that 0, -4. I'll be going up, so I'll put this here. And then 3 times y is a product, so if I let y equal 0, it's like covering it up, and I can see x is 6. That's your x-intercept. That's your y-intercept. If I don't see the numbers 0, -4, and 6, 0, and a line with some arrows, you're not getting one of those from me. I do not want you having to solve that for y to put it in mx plus b form. It's a graphing form, and I want to know if you speak that language. So you'll see one of those every day for the rest of the term. And after midterm, at least, maybe at that point, you'll see one every 3 or 4 days, or maybe just on tests. But you're going to see it so that you get a lot of reps, and you might remember it. Perpendiculars. All right, that's in a different video. I think it's in 1 through 15, or the first 10 problems on a different worksheet, but I've already talked about that relationship. But let's use the standard form to graph. So x-intercept of 6, y-intercept of -15. So we got something that looks like this. Probably steeper than that. It's definitely steeper than that. 6 units and 15. It's 2 to 1. So let me get rid of this. Let's try to use that as 6 units. And then 2 of them and a half is, oh, the 6 was over here. -15 was here. All right, so that is a better representation of the slope of this line. And I think perpendicular. All right, so this is really 15 units down. So up 15 over 6. So we have a 15 to 6 ratio of change, rise over run. which is really a 5 to 2, right? Oh, 5 to 2, and I can kind of see the numbers 5 and 2 there. Oh, so let's look at the perpendicular and let's get it through -3, -7. All right, so let's erase that. -3 at that sixth and halfway, -7 might be about here. And I'm guessing that that is my perpendicular. And that sure looks like it might have something to do with 15 down 6 as a ratio. And it turns out, yeah, 15 is the change, horizontal change, the change in X in this case, right? Change in Y is 6, and that's a 2 to 5 ratio, but it's decreasing. Oh, the original slope, the perpendicular slope. And I'm seeing, oh, boy, there are some numbers up there. Huh. All right, so what's the perpendicular? That's the perpendicular, the one that's going down, decreasing. Remember, this is increasing. We read from left to right. And it looks like it's -2/5 times what? X plus 3 minus 7. And there's our perpendicular to the original line. All right, we're going to multiply. You've had an Algebra 1 class. I'm not going to explain this. If I have to, come for extra help. X squared minus 4x minus 5x plus 20. Okay, and so that's x squared minus 9x plus 20. How do we check algebraic simplifications? We plug in a number. I'll plug in 6. 6 minus 5 is 1. 6 minus 4 is 2. If I plug in 6, this better come out as 2. 36 minus 54 plus 20. Ah, that's 56 minus 54. You know what? I think I can write this product as this sum and difference. I think they're the same. Now, why might we, did I write it correctly? Yeah. Now, why might we do that? Well, guess what x minus 5 is equal to? X squared minus 9x plus 20 divided by x minus 4. We're going to do those long divisions, but in a different way than the textbooks. So let's write this product. Well, you've had Algebra 1. I'm just going to do it. You're taking out the greatest common factor. 5x squared exists here, and 5x squared exists there. So if I take 5x squared out, I need an x to get back to that, and I need 4 times 5 is 20 to get to that. And again, let's put the number 1 in. You put 1 in, this is 25. Let's put a 1 in. That's 5 times 1 plus 4. 5 times 5, 25. Yes, I can make that statement. Yes, I can say that this is equal to 5x squared times x plus 4. I think I may write it that way. Okay. All right, let's keep going. Make sure that you can see. The last video I did, I didn't put this up high enough. Products. So it looks like we're multiplying something. The factors is 6 or 1 and 6 and 2 and 3. And we're trying to get 1 unit there. I think I can combine these units to make that happen because this is a coefficient of 1. I think I can say x minus 3x plus 2. 49 minus 25 happens to be 7 plus 5, 7 minus 5. Geez, 49 is a square. That's its square root. 25 is a perfect square. That's its square root. I guess I can write it as the sum of the square roots times the difference of the square roots. 7 plus 5 is 12 times 2, 24. And I think 49 minus 25 is 24. I guess I can write it as a difference of 2 squares. What's the greatest common factor? You're going to hear me say that. That's the biggest thing. 8 and 6 have in common. The number 2. What do x and x to the 4th have in common? 1x, the smaller exponent. What do y to the 9 and y to the 8th have in common? Y to the 8th. Y to the 9 is y to the 8 times y. So I can take a y to the 8th out. What do I have to multiply 2 by to get 8? 4. What do I have to multiply x by to get x? 1. What do I multiply y to the 8th to get y to the 9? Y. If you multiply that, you get that. 2 times 3 is 6. I need x to the 4th. I have 1x. I need 3 more. Y to the 8th is already there. So that is another way of expressing that sum. And that's called factoring. I like to say, change this sum to a product. so you know what factoring is. All right, so we're gonna sketch, then put in graphing form. Well, it's already in graphing form. So what do I see? Obviously, I did that because this is a +2. The bigger the number you use, the bigger the area. Now, there is a smallest area. We looked at it geometrically from a bunch of different videos. I want to get 0 squared. So what's going to minimize this? The number 3. That's going to be giving me my minimum number and making this a product, right? We want products to equal 0, -3. +3 makes that happen. That covers this up, giving me an amount of 4. And then all I have to do is plug a 0 in to get the y-intercept. I think it's important to have this curve go through the proper place on the y-axis. And that gets me 9 times 2, 18, plus 4 is 22. 0 gets you 22. There you go. It's graphed. So x -3 squared has a minimum area at x equals 3. And the y value is the minimum area. So if I ask for a minimum, looking for a y value. Moving right along. So what happens when it's written in a 2x squared minus 12x plus 22? We can do it 2 ways. Cup shape up, again, because it's +2. We can look at completing the square really boils down to minus b over 2a, which I will talk about conceptually the rest of the term. Right now, we're just going to do the mechanics. Minus b is +12. 2 times 2 is 4. Oh, this is at 3. All right, let's find the y value. If I plug in 3, let's not do it there. Let's do it underneath. 3 squared is 9 times 2 is 18. So that's got to be -36, or I don't have the right number. There's a 2-to-1 ratio, a positive and a negative as well, or a negative and a positive, but they have to be opposite signs. And the second number has to be twice the first. I'll explain that as we go along. Plus 22. Whenever you put these two together, you can either take the negative of the first term, or you can divide the second term in half. Minus 18 plus 22 is 4. Oh my goodness. I guess if I multiplied that last problem out and expanded it, it would have started this way. Because I know what I get when I put a 0 in. 22. Now this is all about quadratic change. What is the quadratic change from 3 to 0? I'm not showing that, am I? Okay, what is the quadratic change on a normal line from 3 to 0? It's actually 9. Quadratic change is about squaring the side length of a square. And from 3 to 0 is 3 units, but when I square it, I get 9 units. Okay, so if I went back 3 units and squared it, I should go up 9. But I went from 4 to 22, which is actually 18. Geez. I wonder what I have to do to the 9, the squaring process, to turn it into 18. If you said double it, you'd be right. All right, just planting some seeds here. Okay, so here's the next one. Let's take 2, 3, and let's put it through 7, 11. Okay, so it's cup shape up, right? My y values are going from 3 to 11. So let's put a 2 here and a 3 there, and let's plot 7, 11. And let's see if we can write this quickly. 2, 3 means I'm saying x -2 squared plus 3. And I can just immediately start to do that. That minimizes, right? That's a minimum area. And I can put a 7 in. And if I put a 7 in, then in this calculation, I get 25 plus 3. And I want to get to 11. You know, I don't think that works. I think when I put a 7 in, I want to cancel that 25 units, right? I'll try to put a little 7 there. Can you see 7 -2 squared? I think dividing by 25 gets that out of the picture, because I want to get from 3 to 11. I wonder how you get from 3 to 11. If you set up 8, you just graphed that. You just wrote that equation correctly. We're going to do a bunch of those in class. I have faith in you that by May 15th, you know how to do that. And you'll be able to speak that language. All right, I hope you did some functional notation in your Algebra 1 class. I don't take anything for granted anymore. All right, so what does f of -5 mean? It means if you pick any x, the f calculation tells you to square it, double it, and add 3. I'm picking an x. I'm going to square it. I'm going to double it. And I'm going to add 3. That gets me 53. So what is f of -5? 53. How do I find y-intercepts for f? Well, you got to look at the y-axis. All right, y-axis has a 0, 0. It's got a 0, 1. It's got a 0, 2. It's got a 0, negative 7.35. Right, but there is something in common to all those points. And it sure looks like the x value is 0. So we're going to do f of 0. What are we going to do with 0? We're going to square it, we're going to double it and add 3. So what does f of 0 equal? 3. So that was the y-intercept. This is graphing form, by the way, right? That is a perfect square. What makes it the smallest area possible? No side length, 0. So actually 0, 3 was the vertex. And to nail this, you probably should nail some other point. Let's put a 10 in. 10 squared is 100, 203. All right, not drawing to scale, obviously. Okay, but you should have another point. All right, we're going to do the same thing to g. So what are you going to hear all term when you want to find a y-intercept? G of x over there, x squared minus 2x minus 3. Yeah, let x equals 0. 0 squared minus 2 times 0 minus 3. I think the y-intercept at 0 is negative 3. We're almost done. All right, so here's a composite. I like composites. I like explaining the chain of these things. F of 2. Oh yeah, F is over here. F was doubling the squaring process plus 3. So we're going to double 2. 4 times 2 is 8. Plus 3 is 11. So if I did F of 2, then I get the number 11. What's the G function say? Square 11, which is 121, minus 2 times 11, minus 3. This is called evaluating the function at 11. And what value do I get at 11? What y value do I get? 121 minus 22 is 99. 99 minus 3 is 96. And that's just evaluating G of f of 2. All right, it's going to sketch f of x. We already did. Let's sketch g of x. So I can erase this now. And we're going to look at g of x from the product perspective. Because I can see this can be written as a product. X minus 2 times, I'm sorry, x plus 2 times x minus 3, right? The negative wins out. Pop, no, Jimmy, come on. End of the video here. Starting to get a little crazy. All right, so is that correct now? X minus 3x, yes. 1 times negative 3, yes. Plugging a number in. Let's plug in 2. So that's 4 minus 4 minus 3. That's minus 3 when I put a 2 in. And this is 4 minus 4 minus 3. And this is 2 plus 1 is 3. Times 2 minus 3 is minus 1. Oh, they are equal. Yes. Oh, so I can trust this. And I know it's a positive x squared. I know that. And it's a product. And we want one of the factors to equal 0, which means negative 1 gets me a 0. And so does positive 3. And I think there's an axis of symmetry in x that's right in between those. And the average gives me 2 divided by 2, x equals 1, which is also minus b over 2 times a, 1. How do I find what goes with a 1? I'll use this. 1 plus 1 is 2. 1 minus 3 is negative 2. Whoa, same number. Something to do with the squaring process. And that's that. So I sketched from the product perspective, which I hope you did a lot of in Algebra 1. All right, so one more time. You heard it before at the beginning of the video. Square root of 2 is approximately 1.41. So why don't we cut that in half? And that's approximately 0.71 on a calculator. Let's cut that in half. Boy, we're going to be cutting these in half a month from now, significantly. And that's about 0.87. That's good enough. Got to have a feel for numbers. All right, I'm out of breath, but you can play those over again. And your grade comes down to how many of those things you can do. So good luck.